Hey guys, it's Brian Goff here with ParaFlight. We're based out of New Bern, North Carolina. The website is paraflightnc.com. You can get our information off there. We are a full flight school. We do paramotoring, some light aircraft maintenance stuff, ultralight stuff. So I have an aviation maintenance background. We got a Moster today from a gentleman in Florida. He keeps telling us that it overheats. He's had it rebuilt a few times. The motor's overheating and he keeps putting holes in the piston. Typically that's a carburation issue, but we've got the engine here and we're going to take a look and see what so here is the Moster. He has the heat shroud on there, the carbon fiber heat shroud, which is supposed to flow air over the head to keep it cool. So we're going to start tearing this thing apart, and we're going to look for the culprit. And as we do, I will make little increments of updates here for you guys so that you see what I'm doing. So I just took off the boot, which is what holds the airbox on there, and you can see there's a pretty good gash in there. That wouldn't really have anything to do as far as overheating. However, that air getting in the side of that, it can offset the flow of the air going into the reed valves, which we're going to get into here in a minute. And it can allow a little bit more airflow in there because you've got air getting sucked into the side of the rubber. So basically you're going to require more fuel because you got more oxygen and it's going to run lean. It can run itself lean. So I highly doubt that would be, it may be a contributing factor, but it would not be the culprit. But it definitely needs to be replaced. So as we continue to break it down, I will show you any updates that we do. All right, so I have pulled off the airbox housing or boot, which is what the airbox gets attached to with the, basically it's a pipe. It's like a pipe clamp. And you can see that the screws or the Allen keys, they're little 5.5 mil Allen key long screws that go through the carburetor and into the reed valves. You can see where they've been cracked. So that creates a lot of extra air going into the reed valves into the carburetor, which means the fuel is going to be, unless it's extremely rich, it's going to run extremely lean. There's also a lot of oil. I'm not sure what the brand of oil was in this machine, but there's a lot of oil and it's not even burned. I mean, most of the time it's just like it turns into like a jelly. This stuff is actually, it's almost like it's got fiberglass pieces in it. It's kind of weird. But you can see where it was cracked. And apparently somebody tried to rebuild this or made an attempt out of doing it, but they either didn't know what they were doing or didn't understand the physics of a motor. So I'm going to also point out another thing, which isn't too big of a deal, but a lot of you guys like the pinch here, the throttle linkage there. You've got that little piece that sits in the carburetor. Here's your carburetor. It sits right here in the little butterfly that opens and closes, and it's got a C clamp in there. Well, when you pinch that, you basically ruined it. So in order to replace that cable, you got to open that back up. Well, if you keep sticking a flathead screwdriver in there and opening and closing, eventually you're going to weaken that metal and it's going to crack in flight. You're going to lose your throttle capability. You're going to have to land and order a new piece for $1, basically. So it really needs to be replaced with the proper pieces and parts if you're going to do it right. All right, so here is the reed valve, and the reed valve is the little wedge that is going to fit right in here. You can see the base gasket reed valve, and then there's this top gasket on the reed valve. And then if you look inside of that, I'm not sure if you can see it, but you can see the bottom of the crankcase. So if you look in there, you can see that there's like two little copper washers that are around the needle bearing, which is that thing in the middle there that is kind of reflecting the light. Well, you want to make sure that those copper washers are good. Those are oil It's like an oil washer, an oil bearing washer. Those are really important. It eliminates slop, and a lot of times those will crack, and you guys just rebuild the engine, and everything's good to go. And then all of a sudden, something will seize up, or you'll throw the connecting arm to the bottom of the crankcase. So you definitely need to check that. And this motor apparently is seized because I just went to try to turn the prop pulley here, and there is no way that thing's moving. So it was seized pretty good, and I noticed that there's some metal shards and stuff like that in the reed valve. So a very easy way to check the reeds is you're going to hold it up here to the light, and you're going to look in the middle, and if you see any light coming through the carbon pedals, you need to replace those carbon pedals. Those little reed valves vibrate under harmonic vibrations very fast, and it's like a fuel pump that's basically sucking fuel into the engine. So if you have air flow in there, your engine's going to run very poorly. At mid-range, you'll kind of get that chirping sensation in there sometimes. And every now and again, you'll get the carbon fiber that'll break. And if you can see that the carbon, the right pedal there, you can see there's light coming through. So the pedal is shot, and it's just from wear and tear. I mean, they're pretty inexpensive, and they only take a couple seconds to replace. You're just going to take those two little screws out on both sides. The one thing that I can tell you is do not bend this right here, this little piece of metal, to make the carbon pedals lay flat. That is not the fix. You have to replace the carbon pedals. So back to one more thing, the gaskets. You guys ask me a lot of times, when do I change my gaskets? Well, typically about every 100 hours you should change the gaskets regardless of how good they look. But do you see how that just crumbles? I mean, it literally just, it almost feels, it's like a candy shell on an M&M. That is a gasket that is done. It's time to get rid of it. Don't salvage it. Don't reuse it. They're a couple of bucks. You are flying the cheapest form of aviation in the market. Spend the $21 and get all the new gaskets that you need and put them on there and start over fresh again. It'll save you a lot of hassle in the long run. Okay, so I'm now starting to pull the exhaust parts off, and this nut, which you could see somebody manufactured there based on the hacksaw job, that is not the nut that needs to be there. It needs to be a lock nut. It needs to be a 10mm lock nut, which is the same nut that they use on the head bolts, just because of the heat that comes off of the extension here on the exhaust. So because of the heat going through that stainless steel bolt without having a heat nut on there, it has actually melted the plastic here, which or the rubber gasket or the grommet or the exhaust dampener. And these are different softnesses and hard. There's certain ones that are harder than others and softer than others. So those rubber dampeners are very important for the vibrations in the engine, so when you're flying, the harmonics are absorbed by these so that you don't end up breaking your exhaust. So those of you guys that have all these issues with the exhaust breaking, you can see here that somebody welded something. I'm guessing this one did at some point. That's because you're doing jobs like this. Well, that does not work. I know it's a paramotor, guys, but it's still aviation. You're leaving the ground, and it needs to be replaced with an OEM part. Now, there's definitely certain things on here that you can do with your local hardware and your Harbor Freight and your Tractor Supply stores, but for the most part, if it's a integral part of the motor, it's there for a reason. The engineers don't design this stuff just because it looks pretty. It's just designed like that for a reason. So it's important that you replace it with an OEM part, and these things are not that expensive anyway. So if any of you have taken off the exhaust, you know that once in a while that these bolts will back out with the nut. Well, I could tell you that that is not the nut that comes on this motor, and you could see the hack job on this bolt here. So you can also notice the two different size springs. Well, those spring tensioners are there for a reason, and the tension on those springs are purposely set for the vibration on the motor where it feeds into, you got a male-female part here. So we've got two different tensions, one on the backside. That's why if you notice, there's all of this oil, if you look here in the fins, that's spewing out everywhere because the springs on the exhaust are not equally tensioned. So again, back to OEM parts. I mean, yeah, we can fix it to make it work to get a couple more hours out of it. But if you're looking for longevity, this is not how you're going to do it. All right, so we've got a majority of this off. This exhaust gasket here on the manifold side is absolutely shot. I mean, it's so brittle. These appear that somebody has hacksawed those because the original studs probably came out and they just hacksawed them. I have no idea. Look at this. I mean, this thing's loose. I can turn it. I can turn it in the actual unit. No idea how they put that back in there. And then up top here, guys, two things. If you notice here, do you see the little top of the spark plug that you can see it spinning? Okay, that is not supposed to be loose. You lose a major amount of electrical current going through the diode in the spark plug when that's loose like that. And your motor will still run, but it's going to spit and sputter. It's not going to have mid-range. And I mean, I can almost take this off by hand. There you go. So the trick is you got to lightly cross thread the top of these spark plugs. And then you should need a pair of pliers to get that back on there. I typically use like a pair of plumber's channel locks to hold the actual, like the 14 mil section. And then I'll use like a pair of needle nose, or I'll use like a pair of like just a D-nose plier head like that, and I'll rough it. I'll rough the threads, and then I'll put this back on there and rough that up a little bit so that it's got a good bite inside of the plug cap. But as you can see, this just basically fell off. So this also, the head bolts on this, again, the cooling shrouds, you know, some people swear by them, and I'm not a big fan of the cooling shroud. I mean, if this engine's dialed in, you know, properly, I've never had my Moster typically will run between like 356 on climb out. It might get up to like 387, you know, just under 400, and then it cools down once you level off. And I mean, that's a tandem full power for 4 or 5 minutes. And then it'll cool back down into the 360s, 370s. And then normally solo flying, it's down like around 340 to 356. So the cooling shroud, you know, I don't really find does a whole lot. You do have to change these head bolts for the cooling shroud. Well, again, we're not using a locking head bolt. So you're going to get a gap in here in the head. So you're getting more oxygen in there, and you're going to eventually burn a hole in your piston. So we're about to pull the head off, and we'll see the inside of the guts here in a second. So I want to show you, I'm breaking the head bolts here with just a regular socket wrench, and I got to hold so let me try this one so that you can see it in the video here. I mean, I'm barely putting any torque on that. That's supposed to be about 18.9 Newton meters, about 14 to 15 foot-pounds of torque on each one of those locking head bolts. Those are not locking head bolts. I mean, I can do that by hand. I mean, that is just, that's why it's burning up. You guys want to know, I'm telling you why. So order original manufacturing parts. If you don't know what you need, call me. I will post my number, my email, all my information on the video at the end of the video when I post it online. And again, the website is simply Paraflightnc.com. You can contact us, and I can give you advice, or I can video chat with you and walk you through an issue if you have one. All right, so the head is off. The head gasket is in pretty good shape. I mean, it looked like somebody tried to rebuild this and just didn't do it right because they didn't have the right parts, or tried to do it kind of as a half-assed job. So there's a lot of little nicks on there. You can't see it in the video, but it happened when it overheated in the engine when the spark plug started to burn a hole in the piston. And that's not even that bad. It's a mild indentation in the piston. I mean, I've seen them burn all the way through to the needle bearing before, and the bearings in the needle bearing is all in the bottom of the crank. So it'll be relatively easy to probably pull it apart. I hope we can salvage the jug, because the jug is the expensive part. They usually use like a nickel, or sometimes they'll use like a magnified like an iron that they will line the they use there's a material with called amalgam that they use, kind of like what you use in like a filling almost, but it's much higher, much more temperature, but typically it's a nickel, and it's typically a cheap nickel at that, because it's a two-stroke engine. So you don't really see any indentations or anything like that, and that was because the engine never really had the right torque on it. So there's a lot of oxygen getting in there. So that it didn't take long for that to put a hole back in it once they rebuilt it. All right, so we got the head off, and you can see the piston has major damage. I mean, it basically got so hot, it melted. It literally fused the rings. It melted the rings into the piston, which is pretty crazy because it's pretty high temp metal. The jug is maybe salvageable. I mean, I got a refinishing tool that will run through that and see what we find, and then a little laser caliber that'll determine the depth of any of the gouges that are in there. And then obviously, if it's not something that's repairable based on the, what the rings on the piston can scrape off, then we're just gonna have to replace this jug piston. Whenever you get anything like that where it gets that hot, you have to replace the needle valve, or the needle bearing, which is on the inside. I'll show it to you here in a couple of minutes. But anyway, the rest of the motor looks pretty decent. This just looks like a lot of hack parts, like not really lined. The parts that were ordered for this engine were not definitely the original parts. And the base gaskets and stuff, the head gasket, it looks like it's those were new. But it just didn't have the rest of the components that were properly, the locking head nuts, the washers were wrong. I don't know if they even gapped. These are, 0.03 or 0.05, or I mean, they're so thin, they're paper thin, obviously. But each one of those determines the top of the stroke of the piston. So as it comes down and comes up, that's what that little base gasket does there. Normally on motors, it's like a 0.03 or something like that. So we will continue to kind of prep and clean up, and then make a parts list here. You can notice that the little back pressure port there is completely clogged up with metal, and it has a lot of carbon in here. This is a pretty new jug. This looks like they bought it new, and then within probably an hour of the engine running, they seized it again. So that needs to be drilled out. You have to be very careful when you drill it out. If you're having problems starting your motor, it's not starting on the first, second pull, that's 90% of the reason why, because that builds up with carbon from the oil and stuff in the gasoline. So you need to take a little drill bit and drill that out. You got to be careful not to score the wall though, because it's very easy to do. And then I use dental picks too to help kind of break it loose to get the bit down in there, and then I'll put a little bit through it. So more to come as we start pulling it apart. The next step is going to be to pull the little clips here out of the piston, which are right in here. You can see it, there's like a half moon clip. So I'll pull that out, and then I'm going to lightly tap that out. I usually just use a socket that fits in the diameter of the clip on the other side, and then we'll slide that out, and then we'll pop the piston off, and we'll be able to see the needle bearing, and I'll show you that here. So I'm going to support the piston from the bottom side. I got the clip out on the bottom, and I'm going to support the piston. You can see that socket fits right there inside of this clip. And I'm just going to lightly tap that with the soft blow hammer. But I'm going to support the piston. Don't hammer it on the connecting arm, because you can mess it up in the bottom of the crankcase. All right, I got the piston off, and I'm looking down inside of the crankcase, and I can tell you, as I told you earlier, you need to check those little copper washers there. There's like oil bearings down there, and then you got your needle bearing in the bottom of that, which the needle bearing looks good. There's no discoloration or anything like that. The copper washers look good as well. So other than all the prep work, you got to scrape all this off. I use a flat edge razor, get all that off. I use a little wire brush and clean it up before I put the new gaskets back on there. And unfortunately with this motor, I do not have this amount of parts in stock to rebuild this. So I got to make a parts list and I got to go in there and order it. One of the other things too, guys, is this vacuum hose here. That's a very important piece of the engine. I had a Parajet, an old Parajet engine, a 172 here a couple months ago, and they had it to a couple of different people, and they couldn't get it running right, and I ended up pulling the motor apart and checking. I literally checked everything, and it ended up being the length of the vacuum hose. So how do you figure that out? Well, you got to be kind of either an aircraft mechanic or a freaking mathematician here, because that volume is what's in the bottom of this case. So I had to get the dimension of airflow in here, which affects this vacuum here, which goes into your carburetor. So once I figured that out, we started messing around and nipping like two or 3 millimeters off at a time until we finally got the right, we just had it long, and then we kept shortening it until we got the right length. And once we got the right length, it was a brand new engine again. And it was a very simple fix, but it was unfortunately a very long time to figure it out, because we thought that there were carburation issues, and then we thought there were reed valve issues, and all it ended up being was this little vacuum hose here. So that vacuum hose is important to replace probably every 100-150 hours. It'll get real soft and pliable, and you definitely want to order that as an OEM part. You can get it through me at ParaFlightnc.com, or you can order it at Aerolight. Aerolight down in Miami. Javier and Jose are great guys, and when they have everything in stock, it's usually on your doorstep, priority mail in a couple of days. So it's a great resource for parts.